Hello, and welcome to our fourth podcast in the Marine Industry Podcast Series. We again continue our discussion with Jan van Oos, Vice President of the Marine Industry at Siemens Digital Industries Software, and Dale Tutt, Vice President of Industry Strategy at Siemens. Both Jan and Dale have an extensive background in their respective industries, each holding leadership and managerial positions over several decades. In our previous podcast, they discussed several points, including ship design, simulation, digitalization, maintenance, and shipbuilding. In this fourth podcast episode, we plan to drill down further into sustainability, which has been discussed earlier, including discussions around hydrodynamics, aerodynamics, fuel consumption, efficiency, and eventually rounding out our discussion with Jan's perspective on the future direction of the shipping industry. So let's kick things off with you, Dale, if you don't mind continuing where we left off in our last podcast, addressing what Jan was saying about opportunities for sustainability.
Yeah, so my first follow-up question, I guess, is do you see opportunities where you might see companies designing retrofits onto some of these vessels to help with improving the sustainability? And you know, one thing I was thinking about is you know what you said was so insightful about you can slow down and everyone believes that you will, you know, use less energy when you slow down. But just like aerodynamics for an airplane or a car, those are often optimized around a certain speed. And when I've seen some of these, you know, like for example, cars, that a lot of times they're designed to be most affordable or most fuel efficient, say operating at 65 miles per hour. And so when you slow them down, they actually are less efficient. And so, you know, when you think about the vessels and they're designed around a certain speed, the hydrodynamics around a certain speed, that it's not as simple as just slowing it down. So how much opportunity do you see for retrofits on a lot of these large ocean-going vessels over the next few years?
Yeah, Dale, you are correct. And let's say slowing down is easier said than done. But if you have a container vessel designed for 70 knots, if you're slowing it down to 40 knots, then it's not optimal anymore because the hull has been designed for 70 knots, the wave pattern, etc. So what a lot of companies did, they modified the bulbous bow because the bulbous bow is reducing the wave, the bow wave at a certain speed. But if you slow down, that bulbous bow is not effective anymore at that speed. So what you saw is that a lot of those vessels are being converted. They completely took away the bulbous bow, or they made it give it another shape so that it is again effective. So there is more than just slowing the speed. You also have to look at the hull, how you can improve then the hull that it's optimum again with that speed. And of course, you cannot design the hull completely in a new way, but you can look at the bulbous bow, and you can also look at the rudder, the propeller. You can have some smaller ducts in front of the propeller where you can guide the water better to the blades so that the propeller itself is more efficient. So there's a lot of things being done with small design houses, but also with suppliers where they are improving the efficiency of existing vessels by adding those ducts or redesigning a bulbous bow. And if you look at the wind, that's also let's say a typical thing. Let's say ships are not sailing that fast. But you see now also that designers are more interested in the resistance part of the wind, especially when you have a container vessel with these stacks of containers on top of the ship. That they say, okay, those are just rectangular boxes, so let's say the wind resistance is quite high. Yeah? The rectangular box is not good for wind. And you see now also that they let's say more like wind guidance constructions on the bow of the ship to reduce the resistance of wind and storm. And when the ship is sailing at, let's say again, the 70 knots, that maybe is not so important, but if you are sailing in a storm and you have quite some headwinds, then it's becoming more important. And even if it's just 1% or 2% of the fuel consumption, it's already quite a lot of costs which you can reduce. So also in that part, say the simulation and the sustainability is affecting the marine industry.
Well, that's pretty cool. You have to worry about both hydrodynamics and aerodynamics on a ship. I wouldn't really thought about it that way. So that's awesome.
That's correct. And let's say the aerodynamics is a little bit newer for the slow sailing vessels. Maybe for fast yachts it was already there, but it's quite a complex industry.
Awesome. Awesome.
So, Jan, when we talk about implementing digitalization to make a ship more autonomous, could you kind of describe what technologies would be involved in that process?
For autonomous ships?
Right.
Yeah, if you look at autonomous ships, in principle, an autonomous ship is a ship like any other ship, except that you don't have the crew on board, or let's say, of a minimal crew. But let's talk about fully autonomous ships. But what is the difference? If you have an autonomous ship, then you need to be in control at all points. And that means that you cannot design an autonomous ship, you cannot operate an autonomous ships without a digital twin. You need to have a digital twin. You need to have the ability to look at the home base, to solve problems, to do simulations, and to control the vessel. So you need all the processes which are on board the vessel, where the data is being sent to the home base. So you have to continuously monitor that and see what is happening, read the sensors, do the simulations, use analytics and artificial intelligence, not only for the predictive maintenance, but also to look, okay, how are my systems operating? And what you don't want to have is that your system are failing, or that you will have a blackout. So you can avoid it by designing the vessel with double systems. Like you have on an offshore vessel with DP3 or DP2, where you have double systems. So if one system is failing, then you still have 50 or 60% of the power left. So everything is divided. Your switchboards are divided, your propeller is divided, your propulsion is divided, even your bridge is divided. So you have two bridges, and that's also with an autonomous vessel. You have to make sure that things are double. So when one system is failing, then you can still, maybe on half speed, but you can still sail to the next port. But before that is happening, you want to make sure that you read and understand all the data, so that you can shut down, or maybe reduce speed because the systems are a little bit overheating. And you can only do that when you can simulate things in a digital twin. So for me, if we are going to the autonomous ships, level 4 or level 5 doesn't matter so much. Then we need to have the full digital twin for operations on board the vessel, but also at the home base. And that digital twin can only really be produced by the shipyard who is doing the design. So therefore, it's so important that shipbuilders are willing to share the digital twin with class societies and the ship owners. And let's say, as long as they don't do that, it is a problem, or the ship owner has to build up his digital twin by themselves. But it's also a business opportunity for a shipyard if you can sell the digital twin, or let's say put it in a subscription model, where you say, okay, I've got a digital twin, I make a service digital twin for you, and you pay me monthly a fee, like we are selling our software in a subscription model, or in a SaaS, even in a SaaS model where you maintain it. Say, okay, ship owner, if you have some changes, give it to me. I will put it in the digital twin, and you can see it and reach it in the cloud. So for a shipyard, it can also be another business opportunity to earn some additional money throughout the life cycle of the vessel. So something has to happen with the digital twin, because the operators need it to fulfill all the requirements around autonomous shipping. But it's the way forward. We are not there yet. The first ships are sailing. You have the drones already. Navies are experimenting with drones. Also, some companies are experimenting with drones. Saildrone, one of our customers, is a great example, where they do all kinds of measurements on the seabed with those drones. So it's the way forward, and it's starting slowly. But I think in the coming decades we will see a lot more of autonomous or semi-autonomous ships sailing around the world. But it's a challenge, and it's also another approach. So you need some other people to operate the vessels, to control the vessels, and to make sure that all the technology is there to build them and to maintain them as well.
Yeah, Jan, I think you've covered some of this already. Actually, quite a bit of this already. Just want to just clarify on one thing. If that. When you think about the digital twin and how you're operating the vessel, and you're bringing that data back from operations, a lot of times we talked about this with the speed that the ship operates at. That are you able to use some of that data that's coming back from the actual operation of the ship and flow that back into your digital twin and use that information to further optimize your the speeds that you might actually be operating at, so that maybe it's designed at one speed, but you can change it to different speed. Are companies being able to use that information in that way?
Yeah, the companies are able to use that information. It's not only about the speed, it's also about, let's say, the other systems on board, which you can optimize. Then you can talk about ballast systems, where you can optimize the ballast. Let's say, with a plane as well, with a ship, if you trim the vessel, you can reduce the resistance. So if you have a system which is looking at the weather, looking at the waves, looking at the fuel consumption, and also control the trim of the vessel, so with the ballast systems, then they can optimize the trim continuously to have the best fuel consumption. So let's say all those information which is coming out of all those sensors is important to control the vessel. And that's already, let's say, one level up in automation, that the systems are assisting the captain in optimizing the way that the ship is sailing. But if you go one step ahead, you can also say, okay, this is the weather information. That's quite good. But if we sail a different course, then we can save more fuel. So there's a depression coming, so we go to the left, or we go to the right, or we go right through it. And most of the captains will say, okay, the depression is not that heavy, I can sail through it. But maybe it's even better to sail around it and save fuel. So that you've got a lot of systems, and then you need to have the data, and you need to have the systems who can analyze the data and then say, okay, this is probably the best course, or this is the best way to sail the vessel, or let's say put the vessel a little bit deeper sometimes as well. So that all the systems connected to each other can help an operator in improving, let's say, the operations of the vessel.
That's great, Jan. Thank you. Before we leave today, Jan and Dale, is there anything else that we didn't cover that you'd like to mention in terms of the marine industry and what you see happening maybe in the near term and in the next 2 to 5 years?
Yeah, there's maybe one aspect which we didn't talk about, and that's quite important for the years to come, and maybe not in the next decade or in the decade before. We will see some parts of it. But if you really look at the future of ship design, then if we look at how ships are being designed, but also how regulations of classification societies who are necessary to design the vessel, because you cannot design and build a normal vessel, a commercial vessel, without a classification society. Naval vessels can be designed without classification societies because they are not insured. But sometimes navies are also following some rules. But a commercial ship needs to be insured, else it is not able to sail. So they have to follow one of the bigger or smaller classification societies. But those rules are often still based on empirical formulas. So you can imagine that with all the technology that we have, with all the simulation, MBZ, but also with FMEA models, that you can start designing a vessel from scratch. So you only have the maximum stress levels, and then you start designing the construction of the vessel without having all those rules about distances, about which profile you have to use, how big is the weld. No, you have only the stress levels, which let's say go higher, because then the ship will break or some parts will be damaged. And then start designing a vessel with a certain construction. And if you then take into account that with all the possibilities with 3D printing and generative design, what you can do with weight optimization, and probably the ships will get a different shape, or the construction will get a different shape. But I think that is where we are going in the coming decades, is that ships are being built and designed in a different way, different than we are using that today. But we need classification societies to change their way of working. We need to change the shipyards, and we have to change the operators, because those ships will be completely different than what is around sailing around the seas at the moment. But we are going in that way. And the first small ships are already printed in 3D, and not directly in steel, but in some plastics which are easily to print. So boats 8-10 meters in length, they are actually already being printed in a commercial production line. So it is possible. The only thing at the moment, I think it's the time is still too long, probably too costly to do, and the facilities are not that big to print those large vessels. But I think we are going into that direction. And what is happening today, some of the castings are being 3D printed, propellers are being 3D printed. So there are already some parts being 3D printed. So the industry is doing already some investigation in it and using some components to see how they are keeping up during the life cycle. But I think that's the way where we are going. And if you are a shipyard today, you need to be prepared to be able to follow that trend in the future. So that I think that's an important thing. It's probably a little further away in the future as what we have discussed in the past hour, but it's certainly let's say the direction where the shipbuilding industry is going.
Yeah, I think I'll just add one thing to that as a great wrap up by Jan. As I look at all the industries and we see so many similarities that the complexity, the amount of smart products that we're now developing with autonomy, with the operations on the ships, and the need to be much more sustainable. I think there's just a lot of times people tend to forget that how important the lessons that we learn in industries like like aerospace or automotive that it's many of the same problems are trying to be solved in marine or in other industries. And so how important digital transformation is and having a good digital twin of your product, that comprehensive digital twin, and really understanding how it operates, how you're going to build it, how you're going to maintain it is critical. And being able to do this in a very flexible and open ecosystem where you're able to bring the best of all of your solutions together in order to help create this comprehensive picture. And as Jan mentioned several times here, having a comprehensive view of your supply chain, whether you're building a car, airplane, a ship, many of the same challenges. And so we're excited to be able to work with so many of these industries and be able to transfer some of those that knowledge across all the different industries. So great discussion today. Thanks, Blake, and I appreciate it.
And thanks to you, Dale and Jan. We're out of time for now, but I appreciate this insightful information today and you bringing out the many similar areas across all industries that are challenges going forward to move to the next level in innovation, using sustainability, a comprehensive digital twin, and the many areas that are impacted by moving to new levels of autonomy. So we've really enjoyed wrapping up some of these areas in this episode that we've discussed in the past 4 episodes, and we look forward to tackling even more pertinent topics in subsequent podcast episodes for this Marine Industry Podcast series. So until then, thanks for listening and goodbye for now.